So this is a review for the 4-1-4-2 quiz. If you take a look at question number 1, what is the common difference D of the arithmetic sequence 4, 8, 12, and 16? Go ahead and try this one on your own, please. So remember that the common difference, all right, the D is what you are adding or subtracting by each time. So 4, 8, 12, 16, what we're doing each time is that we are adding by 4 each time. So that means our common difference is 4. If you couldn't figure that out, all right, the way that you could figure out what the common difference is you could take two numbers that are consecutive, meaning back to back, and subtract them going backwards. All right, remember, you can always subtract them going backwards. So 16 minus 12 does give you that 4. 12 minus 8 gives you that 4. 8 minus 4 gives you that 4. So you could always find the common difference by subtracting going backwards. Remember that if we were subtracting by 4 each time, let's say that our pattern was 10, and then 6, and then 2, and then -2. If that was our pattern, our common difference to that one would be a -4 because we are subtracting by 4 or adding by -4 each time. So if we're adding by 4, it's a 4. If we're subtracting by 4, we write -4 as our difference. Take a look at number 2. Number 2 says, what is the common ratio R of the geometric sequence? So remember, geometric means that we are multiplying each time. Go ahead and do question number 2, please. To get from 2 to 6 to 18 to 54, we are multiplying by 3 each time. So that means our common ratio is 3. Again, the way that we could figure that out, if you couldn't figure out that we were multiplying by 3, when it asks you for the common ratio, you can choose two consecutive numbers and divide going backwards. Divide going backwards. That will give you your common ratio. So 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So that is our common ratio. Question number 3. What is the 7th term of the sequence? 3, -6, 12, -24, 48. Go ahead and find the 7th term of the sequence. So what we are doing each time, we're clearly not adding by the same number each time, all right? Because there's a gap of like 9 here, but then a gap of 18 here, a gap of 36. So we're clearly not adding the same thing. We're actually multiplying by -2 each time, all right? We're multiplying by -2. So this is the first term, this is the second term, this is the third term, fourth term, fifth term. 48 times -2 is -96. -96 would be the 6th term. The 7th term, -96 times 2, is +192. So that's really a geometric sequence with a common ratio of -2. So our 7th term would be 192. Question number 4. Write the next 3 terms in the sequence, then pick out whether it's arithmetic, geometric, or neither. Go ahead and do question number 4, please. So to get from 2 to 0 to -2 to -4, what we're doing is we are subtracting by 2 each time. Or you could say adding by -2. Those two things mean the same thing. So -4 minus 2 is -6. -6 minus 2 is -8. -8 minus 2 is -10. Since we are subtracting by the same thing each time, or we could say adding by -2 each time, this is an arithmetic sequence. Take a look at number 5. Write the next 3 terms in the sequence, then circle whether the sequence is arithmetic, geometric, or neither. Go ahead and try number 5, please. So we're going from -10 to -20 to -40. Remember, if you can't figure out exactly what we are multiplying by, you could divide going backwards. -20 divided by -10 is 2. -40 divided by -20 is 2. So what we're really doing is we are multiplying by 2 each time. -40 times 2 is -80. -80 times 2 is -160. -160 times 2 is -320. Since we're multiplying by the same number each time, this would be a geometric sequence. Take a look at number 6. Circle whether the sequence below is arithmetic, geometric, or neither. So we don't need to figure out the next term. We just need to figure out whether it's arithmetic, geometric, or neither. Go ahead and do this one, please. Hopefully you didn't get tricked on this one, all right? It's not arithmetic because we would be subtracting by 0.4, but then by 0.08. So as soon as they're different amounts that we're adding or subtracting, it's not going to be arithmetic. Is it geometric? Well, when I look at this, at first, I even think, I'm like, it's probably a neither, all right? But be careful. You need to double check, all right? This is really geometric, all right? How do I know that it's geometric? Well, you have to divide 0.1 divided by 0.5, divide going backwards, and that equals 0.2. 0.02 divided by 0.1 is 0.2. 0.004 divided by 0.002 equals 0.2. 0.0008 divided by 0.004 equals 0.2. Because all of them had a common ratio of 0.2, that's what makes it geometric. So be careful. Make sure you try each one if you think that it's geometric or think that it's arithmetic. Don't just assume, oh, it looks weird, it has to be neither. Make sure that you try them out. All right, so be very careful on a question like that, please. Question number 7. Circle whether the sequence below is arithmetic, geometric, or neither. 5, 6, 8, 9, 11. When you take a look at this one, going from 5 to 6, we're adding by 1. Going from 5 to 6, we're adding by 1, but 6 to 8, we're adding by 2. Immediately, because those are different, I know it's not arithmetic. So now looking at our geometric ones, right? When I look at my geometric, it doesn't really look like we're multiplying by the same thing, but you got to try it out. So 6 divided by 5. 6 divided by 5 is 1.2. 8 divided by 6 is 1.3333 or 1.3 repeating. Those are different, so we're not multiplying by the same thing each time. This is a neither sequence. The sequence actually is +1 + 2, +1 + 2, +1 + 2. We're adding, there is a pattern there, but we're not adding by the same thing each time. That's why it's not arithmetic. That's why it is neither. So be very careful there. Question number 8. What is the common ratio of the geometric sequence? Go ahead and do question number 8, please. Be very, very, very careful. Remember, your common ratio is what we multiply by, not what we divide by. So if you put r equals like 2 or r equals divide by 2, that's wrong, all right? Our ratio is only multiplying by. So you might have seen that we're taking half of each one, all right? So maybe you said, oh, we're dividing by 2 each time. Well, we are, but that's not multiplying, all right? So 50 divided by 100. 50 divided by 100 is 0.5. 25 divided by 50 is 0.5. 12.5 divided by 25 is 0.5. 6.25 divided by 12.5 is 0.5. We're multiplying by 0.5 each time. Now, if you wrote the fraction 1/2, technically that is correct as well. All right, technically that is correct. It's just not dividing by 2. We can't say dividing. Common ratio is multiplying only. Take a look at question number 9. In question number 9, draw the next 2 pictures in the sequence. So we need diagram 4 and we need diagram 5. And then answer the 2 questions. Is it arithmetic, geometric, or neither? And is it finite or is it infinite? Go ahead and do question number 9, please. I'm going to give you about 15 more seconds or so. So going across the bottom of this, we have 2 blocks, 3 blocks, 4 blocks. So we're clearly adding a block each time. So we had 2, then 3, then 4. So Diagram 4 is going to have 5 blocks going across. Diagram 5 is going to have 6 blocks going across. We had 2 blocks going up, 3 blocks going up, 4 blocks going up. So this one's going to have 5 blocks going up, 1, 2, 3, 4, 5. And then we're going to have 6 blocks going up, 1, 2, 3, 4, 5, 6. So figuring out whether it's arithmetic, geometric, or neither. Look at the total number of blocks. We have 3 here, we have 5 here, we have 7 here, we have 9 here, and we have 11 here. So look at the total number of blocks. Is it arithmetic, geometric, or neither? We are adding by 2, adding by 2, adding by 2, adding by 2. Since we're adding by the same number each time, this would be arithmetic. Is the sequence finite or infinite? Remember, finite means that it's going to end. Due to something that's going on, like you're going to run out of something or something like that, it's going to be finite. If it keeps on getting bigger and bigger and bigger, and it can't end, it's going to be infinite. Well, there's no restriction on the number of blocks. It's going to keep on getting bigger and bigger and bigger and bigger and bigger. So this is infinite. And take a look at question number 10. This is the last one. Doug's Donut Shop made 100 donuts to sell. They sold a dozen donuts to the first customer, a dozen donuts to the second customer, a dozen donuts to the third customer, a dozen donuts to the fourth customer, and a dozen donuts to the fifth customer. Represent the sequence numerically. Then write down whether it is arithmetic, geometric, or neither, and whether it's finite or infinite. Go ahead and do this question, please. By the way, if you don't know how many are in a dozen is 12. So if they're starting off with 100 donuts, we're going to start off with the number 100. They sold a dozen donuts to the first customer. So 100 minus 12 is 18. They sold a dozen to the second customer. 88 minus 12 is 76. They sold a dozen to the third customer. 76 minus 12 is 64. They sold a dozen to the fourth customer. 64 minus 12 is 52. They sold a dozen to the fifth customer, so minus 12 gives you 40. That's what the pattern would look like. This is arithmetic because we are subtracting by 12 each time. Is it finite or is it infinite? This one is finite because eventually you are going to run out of donuts. We started with 100 donuts, so eventually we're going to run out. The pattern needs to stop once they sell their 100 donuts. That is what your 10 quiz questions look like.